Hi everyone, sorry if there's a little bit of background noise. I'm in the office right now creating these, so we'll start with number 3. The question says, which of the points A, B, or C is closest to the YZ plane and which point lies in the XZ plane? So if we take a look at the typical XYZ drawing that we had from class yesterday, we're asking which one is closest to the YZ plane. I'm going to color in the YZ plane. So to be closest to that, you need to have the smallest X coordinate. So the point with the smallest X coordinate, I should say smallest absolute value actually. So C is closest to the YZ plane because it has the smallest X value in terms of absolute value. Then which point lies in the XZ plane? A point in the XZ plane will have a Y coordinate of 0. So we're looking at A. A is in the XZ plane. Okay, number 5. Describe and sketch the surface in R3 represented by the equation x plus y equals 2. Okay, so x plus y equals 2. So one way we can do this is to just think of the line x plus y equals 2. So there's the line x plus y equals 2. I'm just going to draw it in the first octant just to make this a little bit cleaner. And then because z is not present there, we know that that line kind of gets extruded through space. So if we kind of draw this up like this, there's our plane, x plus y equals 2. It's in front of the z-axis. So if we really wanted to be accurate about this, we could kind of make the z-axis as well as that part of the x and y-axis dashed, and that's what that would look like. Okay, number 6. What does the equation x equals 4 represent in R2? So x equals 4 in R2 is a vertical line. That's like what we studied when we were graphing in different dimensions in class. And then what does it represent in R3? So x equals 4 in R3 is a plane. And it's a plane that's parallel to the YZ plane. So it's a little bit hard to sketch something like this. If we go out to 4, 1, 2, 3, 4, kind of draw that. It's a plane that that is in front of the YZ plane. Again, if we were really to be precise about this, we'd want to make the axes dashed behind it, kind of like that. Okay, next question is number 10. So find the distance from 4, -2, 6 to each of the following. So for part A, the distance to the xy plane, that's just going to be the z coordinate, so that's 6. For B, the distance to the yz plane, that would be the x coordinate, so that's 4. C, the distance to the xz plane, that is 2, because we're talking about the absolute value of the y coordinate there. For D, the distance to the x-axis. So we actually have to do a little bit of work there. So let's try and draw a sketch. All right, so here's x, here's y, here's z. If we're going to the x-axis, I can go ahead and draw where the point is on this one. So 4, -2, 6. So 1, 2, 3, 4, and then 1, 2 this way. So there's the point that's been projected onto the xy plane, and then we're 6 units up. So that's the actual point right here. This is the point 4, -2, 6. So if we're trying to find the distance to the x-axis, think of drawing a triangle that looks like this, and we are interested in this distance right here that I just drew with a question mark. So the up and down height is 6. The distance kind of toward the x-axis along the xy plane is 2. So we're talking about the square root of 6 squared plus 2 squared, which is square root of 36 plus 4, root 40, or 2 root 10. So that's going to be a similar work for all the rest, right? Notice what we did there to find distance to the x-axis. We actually used the z and the y coordinates. So that's going to be similar for E and F. For E, if we want to find the distance to the y-axis, we're going to use the x and z coordinates. So we'll take 4 squared plus 6 squared That's root 16 plus 36, which gives us root 52, which is 2 root 13. And for f, if we want to find distance to the z-axis, we're going to use the x and y coordinates in our drawing. You could add to the drawing, of course, to figure that out, but it would get a little bit messy. So we're going to go 4 squared plus 2 squared, 16 plus 4, root 20, or 2 root 5. Okay, that's 10. 11. Question is, find an equation of the sphere with center negative 3, 2, 5 and radius 4. What is the intersection of this sphere with the yz plane? All right, so finding the equation of the sphere is pretty straightforward. X plus 3 squared plus y minus 2 squared plus z minus 5 squared. The radius is 4, so we have equals 16. Okay, now we're interested in the intersection of this sphere with the yz plane. Well, the yz plane has equation x equals 0. So if we let x equals 0 in our equation, we end up with 9 plus y minus 2 squared plus z minus 5 squared equals 16, which gives us this equation. So we're talking about a circle with a radius of root 7 with a center at the point, at the point 0, 2, 5. Okay, 16 is next. Show that the equation represents a sphere and find its center and radius. Okay, so we're going to complete the square. I'm not going to work through all the work for you. I'm just going to tell you the solution. I expect you to show the work of completing the square. The center is at negative 4, 3, negative 1, and the radius is 3. Next up is 29. So this one says, describe in words the region of R3 represented by this equation or inequality. So we've got x squared plus y squared equals 4 when z equals negative 1. We recognize this as a circle. When z equals negative 1, that just means that it's restricted to only be in the plane z equals negative 1, which would be like 1 unit underneath the floor, right? 1 unit underneath the xy plane. So we could just say circle with a radius 2 on the plane z equals negative 1, or kind of 1 unit below the xy plane. And finally, for 32, x equals z. So x equals z is a plane. It's a little hard to draw, but if that's x, that's y, and that's z. Think of drawing the line like z equals x, for instance, right? So it would be like kind of like this, and then that gets extruded in the y direction. So we're kind of going this way. So again, if we were to make this nice and accurate, we would kind of dash that line like that. And now that sort of view that as sort of coming out toward us, kind of that diagonal plane coming out toward us. And then, right, this plane contains the y-axis, and it contains the line z equals x in the xz plane. Okay, hopefully that was helpful. We can talk more about that in class.